Okay, we have a lot of ground to cover today, and this is going to be the first part of a series on how to save you time, money, and aggravation when it comes to writing your APIs. Many of you are probably aware that APIs are the foundation of most software these days. What I'm going to be focused on today is an opinionated way to create APIs using tools that take away much of the burden of creating entity objects and CRUD operations, as well as providing you with standards like an open API specification that you can hand to other developers so that you don't have to wait for an implementation. You can get other people on board very quickly, and with the conceptual notion of what your data objects and endpoints should be, everyone can start to get to work. We'll start with API authoring and the creation of an open API specification. Now, if you're like me, you don't want to have to learn all of the ins and outs of how to create that specification yourself and by hand. So this first video is going to be on using Apicurio Studio combined with Microcks so that you can have the ability to create these nice specs that you can hand to other developers, but you also don't have to know how to write the low-level YAML that makes up your specification. There is nothing better than the Apicurio Studio for being able to do that. I've tried out virtually everything, and Apicurio Studio is bar none the best API authoring tool that I found out there. And then that in the combination of using that with Microcks, it's super powerful. So the first part of this video is going to be installing both of those. So if you don't want to watch some boring installation, I suggest that you skip right to the part where we talk about using it. But I want this video to be complete because I want you to actually be able to use these things and start saving yourself some time. So we are actually going to go through installing that software on Openshift. It makes developers super productive. And so I want to show you actually getting these tools up and running. And then we can move on to how to use them most efficiently. That will be enough for the first video. Now, having an open API specification does not mean that your APIs will magically write themselves. As much as I wish that were true, that's simply not the case. Now, in subsequent videos, this is where we'll start to get opinionated. I want to bring you as close to your APIs writing themselves as I can. This is a 5-part series. And in many of the videos, it won't matter what language we're talking about. However, in part 2, we'll be talking about the actual code generation. And there, we've had to decide on what language should be used. And I've decided that we will use tooling around Node.js, specifically Amplication and Strapi. They are opinionated, however, they're cool. I will show you how to take advantage of that software to generate your code and then plug it into the rest of the process that doesn't necessarily care which language you're using. In part 3, we'll be talking about how to persist your data. Now, all of these components are going to be running on a platform called Openshift. As I mentioned, makes you as a developer super productive. As a developer, I don't want to be an expert on how to get all of this middleware running on my local environment to best emulate production. However, I do want my development environment to be as close to production as possible. And the database is important to get right. That's why operators on Openshift are so nice. I can spin up large, complex pieces of middleware like a database, much the same way I would if I was installing an app on a mobile phone. So in part 3, we'll be using the CrunchyDB operator to install and manage a Postgres database. And if you want, as a developer, you could even have it doing backups and HA, much like you would in production, so that you can get as close to that production level environment as you can for your development processes. And no API would be complete without authentication, without security, without authorization. So in part 4, we'll be talking about Red Hat single sign-on and how to incorporate that into allowing it to provide the security that your applications and APIs need. And then in part 5, this is a stretch goal. I don't want to put that security code in my application code. I don't want my APIs necessarily to know anything about the libraries required to know who's accessing or who has the ability to access my endpoints. Instead, we will use 3-scale API management combined with Camel K and Red Hat single sign-on so that it can take on the responsibility of knowing who should be allowed to access which endpoint. But not only that, the ability to create complex policies that say, all right, if I'm doing a post, a put, or a patch, that if I'm modifying a specific user's data, that the valid token that I'm being given belongs to a particular user that is responsible for that data. That will make the code I have to write much simpler and put the responsibility of authentication and authorization in a place that is central and I can control much more easily. Why are we doing all of this? It's important to ask that question, and we'll be asking more why questions and answering them as we go throughout this series. High level, it is to show you how to create APIs better and faster than you thought was possible. To get multiple teams and people to all agree on what software actually needs to be built, and how to keep your best people from writing repetitive code that's best left to code generation. That's now possible. Time is of the essence. Don't waste it. Welcome to the first part in our series where we will be focusing on Apicurio Studio and Microcks. This first section, we will be installing both software tools. And first we'll start with Microcks. Microcks being the part that allows you to mock endpoints that you create with your Open API specification so that you can have a client-side developer start creating software using your endpoints, using mock endpoints before an implementation is actually created. That alone saves a lot of time and allows you to get development underway sooner rather than later. So the first thing that we need to do is create a project to hold our Microcks. So API demo Microcks. So we're going to create a project inside Openshift. We're going to call it API demo Microcks. Let's go ahead and create. And the next thing that we do is install an operator. So this is that ability to install complex pieces of middleware in the same way that you might a mobile application on a mobile device. So we're going to look for Microcks. It is currently a community operator. So we're going to go ahead and say install. And then we're going to install it in the project that we just created, API demo Microcks. And we're going to allow it to update automatically. So go ahead and install. It will just take a couple of minutes. And then we will go from there. All right. Let's view our operator. And then we need to create an instance of Microcks install. We are going to be making some changes to the defaults. So go into the YAML view. I do have some YAML that you can copy and paste. We aren't making too many changes, just to the name and to the URLs that will be used for both the Microcks and Keycloak components. The reason for this is I like to use a custom domain name, and I generate certificates using Let's Encrypt. Hopefully you're familiar with Let's Encrypt, to allow that communication between Apicurio and Microcks so that they will be talking to each other. And I like to set up real SSL because that makes the communication between the two work more smoothly when we have to configure the Java Trust store in Apicurio Studio later on, and we'll get to that. So one of the things that you'll do, you'll run a command similar to this, and that will output, and I can show you what it outputs, and we'll be doing some of that in a little bit as well. So if I do ls in this, you'll see that if you do that command from Let's Encrypt, you'll get a cert.pem, a chain.pem, and a full chain.pem that then you can use for SSL communication using a custom domain name. And of course, you'll have to have that custom domain name with the subdomains pointing to Openshift in something like Route 53. Okay, so if we come back here and look at the changes we're about to make. So we've got these URLs using our custom domain name, and we go ahead and hit create. All right, that didn't take long. And you can see there's a number of moving parts, but you didn't have to worry about configuring any of that. The operator did everything for you. There is a bug. If we take a look at the routes that were created, one of the things that will happen is we will have a rejected route because it will try to use the same domain name for both your Microcks and gRPC routes. Hopefully this is fixed by the time you're using this operator. If we had just used the default Openshift routes, we wouldn't have run into this, but we do run into this because I'm using a custom domain. So what I'm going to do is come in here and go to the YAML and then just change this to the Microcks-gRPC. Hit save. It will complain about this being a managed resource. Go ahead and click save anyway. And just make sure that your changes did take effect. And you can see now that we have a route that is accepted for the gRPC location. In the next step, I'm going to go ahead and delete this. So to get our certificates correctly inserted into these routes, let's go ahead and create a temporary dummy route. So temp, and we're going to call it temproute.kflowtech.com. We're going to just pick any one of these service names and ports. We're going to say this is a secure route with edge termination. We're going to force a redirect. And then let's take a look at what Let's Encrypt outputs here. Let's do a cat on our cert. Go ahead and copy and paste that. We'll do the same thing for our private key. Again, I'm just using this for demo purposes, this domain, and I will invalidate these certs after I'm done. Okay, we've got our private key. And let's get our full chain. It's nice being able to apply these certs right at the route in Openshift. Okay, now that we have that, let's go into the YAML and let's grab the TLS section all the way down to this insecure edge termination policy. Let's copy that. Let's go to our routes and we'll click on this one, go to the YAML, and we will replace the TLS section. Post that in. We'll hit save. Go back to routes. And the other one that we have to update is the keycloak route. And then just paste that in. Click save. And now if we go to microcks.kflowtech.com, it will be configured correctly to allow us to log in. Now we need to install Apicurio Studio. This is a bit different. We don't have an operator for the full version of Apicurio Studio. We could use an operator for Apicurito. So if we go into Operator Hub and we take a look at Apicurio, so we've got something called the API Designer or the Red Hat Integration API Designer. That is a minimal version called Apicurito, and I prefer to use the full version of Apicurio. In order to do that, now we're going to use a different method of installation for this type of middleware. Rather than use an operator, we're going to use a template, an Openshift template. So you would go to this GitHub, and then under the GitHub, there is something called the Apicurio standalone template. So under Openshift, Apicurio standalone template, and then I go and I get that raw file. I'm going to save this as the YAML file. Yes. And then I'm going to go to that location. I'm going to bring up my Visual Studio editor, Visual Studio Code editor. All right, there it is. And there's just a little bit of a change that I need to make down here. So this template has a number of properties, and the properties that I'm going to change are all going to be to make the default URLs be kflowtech.com. All right, kflowtech. All right. Okay, once I have that, again, you'll want to go back to your Route 53, whatever your domain name is, and make sure that you have all of those Apicurio Studio domains. So I've got the Apicurio Studio-API subdomain in all of these. And again, they just point to my OpenShift cluster, and OpenShift takes care of the rest on how to route that to the correct container. And if we go back now, let's create another project. So we go home just for Apicurio. So we're going to create another project, and we're going to call it API Demo Apicurio. And API Demo Apicurio, and create. So if that template was already in the system, we could switch to the developer view and then come in here, and let's say we wanted to spin something up. We have a number of options as a developer, right, for running a software. If we just had a repository with source like Node.js or Java, we could use builder images and just have a sourced image spin something up for us. But we also have this developer service catalog, and that points to a number of templates that can be used to spin up software. We can come in here and look. We don't yet have our Apicurio Studio. We just have Apicurito. So what I need to do, now that I made a change to that, I have the OC command line connected to my OpenShift cluster. So I say OC. So if I can, I wonder if I can make that bigger. Hopefully that's big enough. Yeah, there we go. Okay. So I'm making this a little bit bigger. All right. So I just do like OC get nodes to make sure I'm connected to the right cluster. And then I also want to make sure I'm on the right project. So I say OC project API demo Apicurio. That switches me to the API demo Apicurio. And then I'm going to do a dir here. So Apicurio standalone template. I'm going to say OC create -f for file Apicurio standalone template. I'm going to go ahead and create that. Now, if we come in here and do a search, let's come in, let's go back in here to our service catalog, do Apicurio. So now we have Apicurio Studio standalone. And let's click instantiate template. Let's take a look at our defaults. The defaults should be fine. Let's go ahead and create. And this is still the developer view where you'll get a topology map. But let's go back to our admin view and take a look at our pods. And it is spinning up a lot of software again, but not a lot of work on our part. We just let Openshift do the work for us. Now that that's all running, it should look like this. And again, we have to do something similar to our routes over here. So let's go to our networking routes. Rather than create new routes, we're just going to replace the TLS section of the existing ones. So let's go back over to our other project, our Microcks project. So API demo Microcks. Let's go to one of our routes and let's take a look at this guy. Let's go to the YAML. And what I'm really wanting to do is just copy this TLS section all the way down. I actually want our insecure redirect policy to be redirect, but we're going to grab all of this now. TLS, copy, and we're going to go to our API Apicurio, go to our routes. And one by one, we're going to change these. So we're going to go in here, go to our YAML, and we're going to change the TLS section to be this. Okay. Gotta go to our routes. One by one. Save. YAML. Save. And YAML. Save. All right, if we click on these guys now, let's go to our UI. So you'll notice that our certificate is valid. So the connection is secure, certificate is valid, and that's what we want to see. We don't yet have a user for Apicurio. Let's go back into Openshift. And we're still under the API demo Apicurio, and we're going to look at the secrets that were created for us. And we need to log into the keycloak for this one. So let's look at our Apicurio Studio auth secret. Let's reveal those values. We're going to copy that in a new tab, or however you like to. Let's go back to our routes, and we're going to go to our Apicurio Studio auth Kflow Tech, go to the admin console. We're going to put in our admin credentials. Okay. Let's come down here to users. We don't have any, so we're going to create a new one. Add a user, and we're going to give it, so I'm just going to give it mine. User enabled, verified, save. All right, I'm going to make some credentials. We don't want that to be temporary. We're going to set that. Now we can come back in here and go ahead and sign in. So we've got our Apicurio Studio. However, if we create a new API, let's just do this. Test API real quick. Create the API. There isn't anything in here about Microcks. Now it's going to be very useful for you to be able to create your API here, and then with a click of a button, send that over to Microcks to mock out your endpoints. We'll need to get that set up now. All right, here is a little bit of the tricky bit. So we're going to go in where we generated our certificates. So we have to tell Apicurio and Microcks to communicate to each other, and then for Apicurio to display Microcks options. But the first step is to configure a Java key store so that Apicurio will trust the Microcks endpoints. To do that, and again, I'll have the detailed instructions along with this video for you to look at. So we're gonna first, in our kflowtech.com, where we have our private keys and fullchain.pem, we're going to say open SSL x509 outform der in, and we're going to do fullchain.pem, and we're going to say out is fullchain.crt. All right, now we have a fullchain.crt. Now we're going to do key tool. So let's just grab this guy here and copy and paste it. Okay, we're going to say we want our fullchain.cert. Okay, and just to be safe, let's also add the Openshift cluster itself, its domain. I'm using Enterprise Web Service. So if I do this, copy our trust store.jks to enterprisewebservice.com to trust store.jks. Yes. And I'll do cd ... enterprise. Now I'm in here. So I'm going to remove that full chain since I've already done this before. Yes. Okay, we'll do the same thing. We'll go up. To OpenSSL, full chain out. And then we'll do this. But this time we're going to change the alias to cluster chain. All right, now we have a trust store that is ready for us to use. Let's make sure we're still in the right project. I always like to do OC project. Yes. And we're going to run this command. We're going to create a secret for our trust store. So OC create secret generic Apicurio trust store from file truststore.jks. That's created. And then we're going to set that as a volume on our deployment config. So if we do OC get DC, we've got our API deployment config that has to be modified. So we're going to set our new trust store so that the deployment config mounts it on the drive. So we first have to set that volume. And then we're also going to do a patch. Again, I will have these instructions for you. Okay. And it's patched. And we have to do a couple more things. So let's go back here. Let's go to our deployment configs. Take a look at our API. We're We're going to go to our environment, and we have to add a few things here. First, we need to go back to our Microcks, and we have to get the password for our key cloak again. So let's go back and take a look at our secrets and go to our Microcks, reveal values, to our networking routes, open new tab, Kflow Tech, key cloak, here we go. Admin console, copy that. Copy that. And we need to go back into our clients, go to our Microcks service account, and we'll need our credential that's there. So we're going to copy that, copy, and then we're going to go back to our other API demo Apicurio, so our deployment config. We're going to start adding some environment variables. One of those environment variables is Apicurio Microcks API URL will be HTTPS Microcks secure dot kflowtech.com, and add another one, Apicurio Microcks client ID. This will be our Microcks service account that was automatically created for us. Add another one, Apicurio Microcks client secret. And that's where we will put in our secret. And then one more, Java tool options. And in here, we will want to include our trust store values. And all right, so we got that. So copy and go ahead and save that. We will have to modify one more deployment config, and we're going to come in, go to the environment, and we have to add a few things here as well. We'll go put in the API Apicurio Microcks API URL. Here we will do HTTPS microcks.kflowtech.com API. Add another one, Apicurio Microcks client ID again. Microcks service account, and another one, Apicurio Microcks client secret. Oops. So let's just save that for now. Let's go back to our other deployment config. And grab it again. We need that. All right. Go back here. Environment. And then we'll add another one. And this is what triggers Apicurio to actually display the Microcks UI features. Feature Microcks equal to true. Go ahead and save that, and then we will wait for everything to redeploy. Okay, let's go see if everything is working in Apicurio Studio now. Come down to routes, go to our UI, log in, and let's go ahead and create a new API. We'll just create another sample pet store, test 3 pet store, create the API, and it has not yet been mocked with Microcks, so let's go ahead and do that now. Make sure yes, and we have our API mocked successfully. Okay. In order to showcase using Apicurio Studio and Microcks, it's time to introduce our use case. We have a fairly lofty goal of solving the problem of in-game item interoperability between multiple games. We will create an API to help solve this problem. Eventually, it will be an API that's flexible enough to handle the item interoperability between multiple games. However, as maybe many of you have experienced in something called domain-driven design, you only want to create software for the context that you have a good understanding for. So like any good designer, we are going to start with a single game. We are going to design our API keeping in mind that our goal is interoperability. However, we're going to design our API specifically for the game that we're working on. And then from there, as our context and our understanding grows, we can branch out into making our API more flexible for other types of games. What is so great about using Apicurio Studio and the Open API specification is, in order to get that level of understanding that you need to work with a subject matter expert to help design your API and your software. Everyone should be speaking the same language, and Apicurio Studio makes that extremely easy and fun. Without a lot of ceremony, you can efficiently work remotely or in person with your subject matter expert, designing your endpoints, creating your objects that are going to be used in your endpoints inside Apicurio Studio, and you will end up with a very well thought out design. And the process inside Apicurio Studio feels very natural for everyone involved. Everyone can visualize easily the changes that you're making to your API and the reasons for those changes, why variables are being added, and as you're doing your work, you're doing real work. In the end, you will have a specification you can hand to client-side developers so they can get started before the back-end developers have even implemented a single line of code. And of course, you do that with mock endpoints, which is the purpose of Microcks. And we can also generate code from that specification for both the client and the backend. It can generate test cases. It can also generate live documentation. So it's an extremely useful tool when it comes to sharing the vision of what it is that you're actually trying to build, so that everyone is on the same page and speaking the same language. Let's take a look at a representation of some of the gameplay that we're trying to create an API for. This is going to be a push your luck game. You can enter one of 3 different types of rooms, and one of those rooms you'll be fighting a monster, and essentially you have to modify your dice roll to beat the monster's dice roll. You can do that through the acquisition of cards, playing those cards, and purchasing those cards through the use of crystals. Let's look at a different view of the game. This is a flowchart of the gameplay. You'll choose your character, and you can either enter a trap room, a monster room, or a treasure room. At any point, you can choose to leave, and you will get rewards for monsters that you beat or treasure that you acquire. However, if you choose to go to the next room and you lose, either by encountering a trap or being defeated by a monster, then you lose everything that you acquired in the game and that you brought into the game with you. Because we are trying to solve in-game item interoperability, this game relies heavily upon bringing content from the outside world via API. We can't just have the game creating objects or a data model any way that the developer of the game chooses. We want to make sure that the game can speak the same language as our API that is going to potentially be used by many other games. And when I say language, I don't mean Java or Node.js. I'm referring to the objects that will be passed between the games and the data that will be loaded inside the game. So let's start creating our API. We're in Apicurio Studio now. We're going to create a blank API, and we want to use the OpenAPI 3.0.2 specification. Let's call this Dungeon Crawl. Okay, go ahead and hit Create API. Let's go in and edit our API. So we have a design and a source view. The source view is pretty simple from this point, but this is what I'm using Apicurio Studio for, is to get away from having to know this format and really get down into the weeds of writing the source for my OpenAPI specification. I want to design my specification, and I want to design it in a way that I can be interactive with a subject matter expert and they can grasp what's going on in a very intuitive way. Ideally, this would be a session or a live session I could show you with another person, and we'd be designing that and you could see that process. But I'll try to emulate a little bit of, how that should go. So the first thing that's helpful, right? You start with a path. And as I'm thinking about this API, I don't have a lot of context. The people that I'm working with to design this API, they have more context, but we're all creating this API together and it's new. So you'll start out small, and it's useful to have this type of tool to start thinking about, all right, what are the endpoints? What are, the series of things that are going to have to be called in order for the behavior to occur that I want? So one of the things that I can think of that I'm going to need right away is, we need that initial hand. So we're going to create a path called initial hand. All right, we look at our source. So this is just the source of the section for initial hand. There's nothing in there yet. If we go back and look at the source of our entire API, now we have a path called initial hand. We've gotten everyone to agree that when the user plays the game, they need an initial hand of cards. Those cards will be used in the game to increase the count that they have in their dice roll to beat a monster, for example. All right, everyone agrees. Now, all right, what is the content of that initial hand? Well, we know that it's going to be one of get, put, post, delete type verbs when it comes to calling the data. Since we're trying to get something, it's going to be a get. It's very easy for even non-technical people to visually look at this and understand, we're getting something like an initial hand of cards. So let's go ahead and add that operation. Okay, so we can add our summary. This endpoint will return an initial set of cards the user can play in game. Okay. So I'm not having to understand or know anything technical about the Open API specification in order to visually see the things that I need to do to start building my API. All right, the next step is, okay, I want to set up my Microcks so that it can have a viable endpoint with examples that a client-side developer can call to get started creating their code. So I need to come in here and say, this thing can return a 200 response. It's going to be a 200 OK response. And the response body will be what? I don't have a whole lot in here. So now I need to decide and design the actual objects that will be returned. So since this is going to be an initial hand of cards, I'm probably going to need a card object. Okay, so let's go ahead and add a data type. We're going to call this card. We're going to save that. And as part of this, we can create an example, and that will go into our specification. Okay, I happen to have the data model of the card that I want, and I'm going to paste that in. It's fairly complex. So we have a card image. We have an image for when it's going to be equipped on the character. We have a name, and then we have these different modifiers. One for if the object in the card is going to be equipped on the character, and one for if it's just going to be used without equipping it. And some other information like the cost in terms of crystals that it will require in order to use this card. So we can go ahead and say that's all right. And for the purpose of using our specification for code generation, you'll want to fill out the property section here. So if we look at our example, we need to fill out properties for each one of these property types that we have in our example. Now you'll notice that I have some complex object types for equipable modifier and non-equipable modifier. You would want to create a new data type for that. For the purpose of this demo and expedience, I'll just show adding a couple of the simple property types. So we could add the card image. We say that's required, or we say that's not required. And that would be a string. Save that. And let's add, name. Let's go ahead and click another one. Name. Required string. And you would want to do that for each one of these properties that you have in your example. And you would also, again, add whatever data types necessary for your complex objects. And now we can come back to our initial hand and say that our response is going to return a JSON media type. And notice it has no type, but we can choose our type now. And because we added card, it shows up. So we can say that that's going to be a card. Or, right, since this is going to be a hand of cards, it should be an array. So let's change our type to array, but then we can say that our type is going to be an array of cards. And then we can go further and actually add an example return array of cards. As you go along, you might realize, oh, well, the card object has a lot of data in it. So if we're just trying to pass around an array of cards, wouldn't it be better? So your context is starting to expand as you realize the different use cases for this type of object. The initial hand might be better served with something that has a smaller amount of data. If you don't need to, for example, to know right away how much the crystal cost is of a card, for example. You just need to have the reference of the card. So you might want to go back before you start creating this example, or maybe you've already created the example, but it's easy to go with using a tool like this before you've actually done the implementation to change the work that you've done, to change your design. So as your context and knowledge grows together, the people that you're working with, you can go back and say, okay, yeah, originally my initial hand was going to return an array of cards, but maybe instead I want to create another object type or data model or a schema object called player card. All right, what should our player card object look like? I think it should look something like this. Now I have some other variables in here that I know about from having spent more time with this API, but for our knowledge right now, we know that we're going to have a reference to a card ID. So rather than at this point in our initial hand pass around a bunch of large card objects, we're going to come in here, we're going to provide an example, and this is instead going to return an array of player cards. So we can go back and say, all right, this is actually going to be an array of player card. And we can then modify our example. Now it's important to name these. So if you have multiple examples that you want to provide or have Microcks generate endpoints for, then I'll show you what you do. So we're going to name this player hand 1. And that name is important, and it has to match either a query parameter or a path variable in up above. I'll show you in just a second. So let's go ahead and create our example initial hand. All right. So our initial hand is fairly concise. Rather than have to put in all of the different data for a card, now we just have a player card which has a reference to a card ID, and if we need all the other information, we can just go and extract that via this ID. All right, we have an excellent design, I think, started with what the initial hand should return. It is telling us, it's warning us that we do have to have a description, so let's put in our description. And so that we can have more than one example and have Microcks do the work for us, let's come up here and give it the ability to return more than one via query parameters. So we're going to add a query parameter called, player ID. Now this isn't required. If you call initial hand, it will give you maybe a random array of cards, but maybe based on the character state, or the player state, you want to return a specific hand of cards that they've chosen. So we're going to add a query parameter called player ID, and it's going to be not required, and it's going to be a string. We might want to use Red Hat single sign-on subject, and that's a string rather than an integer. So let's save that, and we're going to create another. So we've got a query parameter called player ID. Now we have to define some examples for our player ID. Let's go ahead and say this is where we have to match the name that we use for the actual response names. So we're going to say player hand 1. That will match the response player hand 1. And we're going to say 1. Even though it could be a string, we're going to keep this simple and have an example of 1. All right, let's add another example. We're going to do player hand 2. You guessed it, 2. Okay, but now we have to have something that will actually be returned if we have if we have 2 as our player ID in the query parameter. So let's come in here, and we do actually want to override this to make sure that Microcks is taking advantage of what we've entered for our player ID values. And we're going to add another example. So we're going to just slightly modify this one. Okay, we're going to call this player hand 2. And we're going to just change some variables or values here. Let's do, so we can easily see the changes that we've made. 1, 1, 2, 2, 3, 3, and maybe make this all zeros so that it'll be easy for us to see the difference. And maybe a 1. Okay. So that's enough for player hand 2. Okay. We've got a start of our API. Now, maybe that's enough for, maybe this is the only endpoint that our client-side developer needed to get a start. Well, we can hand them a live endpoint that they can start testing with. In order to do that, we go back to our main page for our Dungeon Crawl API, come in here with mock with Microcks, and we say mock our API. API mocks successfully. We'll hit OK. And we have a handy button down here that we can go and view it in Microcks. All right. We have our APIs. We've got Dungeon Crawl. We can click on that. And what we have here is Microcks now also knows about our initial hand. We can expand this and see our player hand 1 and player hand 2 examples. So we could take this. So let's take this endpoint. Let's go into something like Postman, and let's call it. We're going to create a get, and we're going to put that right in like that, and we're going to hit send. And we actually get back the values that were in our specification as though it was a live endpoint. And client-side developers could use this endpoint as though it was the real thing. They don't have to guess what type of object or values are going to be returned. They don't have to look at code. They actually can use this live endpoint. All right, let's call our other endpoint to make sure that works as well. So if we wanted a variety of data, so we've got player hand 2, come in here, go to Postman, hit send, and now you can see that we have our player hand 2 data returned, and they could put that right into their client code right now. Let's take a look at what our specification looks like now that we've done all of that work. Let's go back to Apicurio. Let's go back to edit our API, and let's take a look at the source. So if we scroll down, you'll see it's getting to be fairly complex. And this is just one endpoint. So imagine trying to write your specification by hand without something like Apicurio Studio. Not for the faint of heart. But Apicurio Studio makes it relatively painless. I would say fun. If you've had a session with, even a non-technical individual designing your API, you'll see that it flows fairly smooth. And before you know it, your API will go from this to, and it's easy to just drop in your specification in a number of different tools, to this. So here I've got a number of endpoints and a lot of different data types that evolved through a number of conversations. Now imagine writing a specification, which still isn't very large, like this by hand. So I much prefer the design view. And modifying, one of the tenets of modern software development is you're capable of evolving your entities and your endpoints. And without something like the OpenAPI specification and a tool like Apicurio Studio that would be much more difficult. Now let's go and see what can be created without even a single line of the actual API implementation being created. Instead, those Microcks endpoints are being used. So if you have your client-side developer, in this case, let's say a Unity developer that is making the gameplay and having to use your API, they can do that by using Microcks. And this data for this little demo here is getting its information from those Microcks endpoints. So you can come in here and actually play it. Say, oh, I want the shield, I want the axe, and you can see the crystal counts are going down. You have a count of 6 compared to the monster's 12, so you can hit submit. Oh, you lose. Going to the next room, setting up the cards, it's applying, there's an endpoint called monster hand, so you see that it applies the monster's hand. And down here in the gameplay data, rather than some random object types, you actually have the representation of your player hand cards that you want with the data coming from Microcks right inside this Unity development IDE. And if we take a look at some of the scripts that are being used in the game, we can see that the data is in fact using this Microcks endpoint. All right. Thank you for joining me today as we talked about how to use Apicurio Studio and Microcks to make your API design and implementation a much more enjoyable experience and more productive. Join me next time in part 2, where we get to the actual implementation of your API. So while your clients are being developed, you can also be working side by side on the actual implementation. So next part, we will be talking about some tools, specifically Amplication and Strapi. A lot of what we're using in this game requires content, things like images and animations. So that I'm going to be using Strapi as a headless CMS system in combination with Amplication to create our actual API implementation and make that so that you have to do as little work as possible and yet have code that's probably better written for your CRUD operations than if you were to, doesn't matter how smart you are, write those endpoints and those CRUD operations yourself. And then lets you evolve your design over time, including your implementation, by making it easy to go back and regenerate your code for the most part. Now, I think that will be interesting. And then we'll also have subsequent videos after that that aren't specific to Node.js, Amplication, and Strapi, but there are going to be things in the next video that I think everyone will be able to take advantage of. So please join me in part 2.